Alright, physics students, yesterday we had a lesson on inclined planes without friction. So if you did not watch that video yet, I would recommend watching it first since I won't be going into as many details on things we already covered. So today we're doing a similar problem as yesterday, but this time with friction. And so here's our sample problem. We have a Byng student on Christmas break that has a mass of 62 kilograms that goes on a ski trip to Colorado. If the student starts at rest on a 37-degree slope and the coefficient of friction between the skis and the snow is 0.15, then two questions. What will be the acceleration and how fast will the student be going after 5 seconds? So you can always you rewind the video to come back to the details of the question if you need to, but we're going to go ahead and try to figure out then what's going on for our skier friend here. So first of all, we need to get our drawing made of our skier. Sorry, I'm not very good at drawing people. So I made a box for the skier, 62 kilograms, and then we take and draw the x and y coordinate as shown, and then show the gravity that is pulling straight down. And so to calculate that force due to gravity, we took the 62 kilograms times 9.81 to get the 608.22 newtons. If you remember from yesterday, then we also then need to draw the x and y components and then find the angle of the triangle. And so there is the correct way to draw the triangle. Remember, it's crucial that the x component, the part down here at the bottom, this has to be parallel to the x in your coordinate system that you draw. So be sure and take care of that. And so now then, we're going to proceed similarly to yesterday and find the x and y components. So to find the x component, we use the sine of 37 since it is opposite of the 37-degree angle, and we come up with a value of 366.04. So I'll put that on here. And then we need to go find the y component. Today we need the y since we will be using it for friction. And so we have that labeled as, let me go back just for a second there, that went by pretty quickly. So there's the work on that. We took the cosine of 37 to solve for the y component. So we did both of those things yesterday. You may want to pause and take a second to make sure you have all your calculations done correctly on that. Alright, so now then, this is where things start getting a little different. Yesterday we would have just used the 366 Newton force as the net force because there was no friction. But this time we do have friction, and so we need to know what is the value to the force of friction that will be opposing that 366 newtons down the inclined plane. So I'm going to go ahead and move on to the next. Okay, that's right. I'm going to go ahead and solve for friction here. To solve for friction then, we use the equation force of friction equals mu k times the normal force. And so in this case, since we had the 485.75 Newton was the y component, then that will also be the normal force because the inclined plane is opposing that with the same value of 485.75. So we can use the mu k, which was given in the problem of 0.15, times the normal force, and we come up with a force due to friction of 72.86 newtons. So which direction will this be pointed? It's going to be opposite of the direction the skier is trying to move. So as the skier is trying to move down the ramp this way, the force of friction is going to be opposing that motion, is going the other way. And so to clean that up a little bit, went ahead and made a new drawing here to show, since the normal force and the part of gravity, the y component of gravity, have canceled each other out. So I could put those on here, but those two things have balanced each other out. And so the only remaining forces then are the x component of the gravity, which is right here, and the force due to friction, which is right here. And since they are in the same line, we can just subtract them and come up with a net force of 293.14 newtons. So now we finally have our net force, and one of the goals then was to find the acceleration. So once we have the net force, then we know that net force is equal to mass times acceleration. And so we can write that out. The mass of the skier was 62 kilograms. So to solve for A, we come up with 4.73 meters per second squared. Then when rounded off for sig figs, we get 4.7. So this would be the acceleration of the skier down the hill, and that would be at 4.7 meters per second squared. That was the first part of the problem, was what is the acceleration going to be. It added one more question to this, and it said, what would the final velocity be after 5 seconds? And so to solve this out, we want to write down the things that we know, which are the initial velocity was 0, we know the acceleration is 4.7, time is 5 seconds, and we're looking for final velocity. And so to figure out which equation to use, you could look up on the board if you're in the classroom. It would be our bottom left equation, which is just the basic acceleration equation that's written right here. And so to plug in the values, we can plug in the initial velocity and time and acceleration and solve for the final velocity. And when we do that, we come up with 23.6 meters per second. Rounding off for sig figs again, we get 24 meters per second. So that would be all of the questions have been answered. That would be about as tough as a problem as we would do on the inclined planes, the ones that I would expect you to know how to do. There might be a bonus problem that we could add some additional details, but if you've got this one down right here, then we should be in good shape on the inclined plane problems.